So today I will be doing quiz correction for acid-base quiz 1B, and the part A asks you to write the expression for the acid dissociation constant Ka for lactic acid and calculate its value. So I did products over reactants to find the Ka, so Ka is equal to H plus times the concentration of C3H5O3 minus over HC3H5O3. And to find its value, I did the standard icebox question. So it was, you know that you have 0.5 molarity initially of the HC3H5O3, and initially you don't have any H plus or C3H5O3, and then you do the minus X and then the plus X for the products. So when you do the products over reactants, you get X squared over 0.50 minus X. But you can solve X by using the percent dissociated, which is 2.25 divided by 100 and multiplying it by the molarity of 0.5. So your X value would actually be 0.01125 molarity. So you use that for X, which would be 0.01125 squared over 0.50 minus your X value, which is 0.01125. And then you use that to solve for your Ka and then you get 2.59 times 10 to the negative 4. Part B, calculate the pH of 0.5 molarity HC3H5O3. So I did this by just using the H plus that I have, and you know that the H plus is going to be equal to your X value, which is 0.01125, and then to find the pH, you do the negative log of that H plus value, which is 0.01125, and you get the pH of 1.95. Part C, calculate the pH of a solution formed by dissolving 0.09 mole of solid sodium lactate NaC3H5O3 in 250 milliliters of 0.5 molarity HC3H5O3. Assume that the volume change is negligible. So to do this one, I found the molarity of C3H5O3 by dividing 0.09 moles of NaC3H5O3, which is given to us, by 0.25 liters, which is also given to us. And you do an icebox. So you know that the initial amount of HC3H5O3 that you have is 0.5, and then you have 0 H plus at this point, but now you know that new molarity of 0.36 molarity of C3H5O3. So then you do negative minus X plus X plus X to get, and then you get 0.50 minus X for your final for HC3H5O3. H plus you get X, and C3H5O3 you get 0.36 plus X. So then you do your standard icebox again, and you equal it to your K value that you found in part A. So it would be 2.59 times 10 to the negative 4, which is equal to X times 0.36 plus X, divided by the quantity of 0.50 minus X. Once you do some simple algebra, you'll get that your X value, which is equal to your H plus, is 3.6 times 10 to the negative 4 molarity. And then you find the pH by doing negative log of that value, which is negative log of 3.6 times 10 to the negative 4 molarity H plus, and your pH would be 3.44. Switching transition here, sorry about that. Okay, part D. A 100 milliliter sample of 0.1 molarity HCl is added to 100 milliliters of 0.5 molarity HC3H5O3. Calculate the molar concentration of lactate ion C3H5O3 in the resulting solution. So for this one, I needed to find the molarity of C3H5O3, so I multiplied 0.5 C3H5O3 times the 100 milliliters over 200 milliliters, which is basically 0.5, so you get 0.25 molarity HC3H5O3, and this is using the numbers given to us in part D. And then you do 0.1 molarity times 0.5, which is 0.05 molarity of H plus. And then you do your standard icebox again, and you know now that your initial concentration of HC3H5O3 is 0.25 molarity, right here. And then your initial concentration of H plus is 0.05, and as of right now, you have 0 of the C3H5O3 minus. So then you're going to do the standard minus X plus X plus X, and then you're going to do your standard icebox problems with products over reactants, which is going to be 0.05 plus X times X over 0.25 minus X. So your Ka is going to be equal to 2.59 times 10 to the negative 4, which is equal to 0.05 times x over 0.25, which is, we just basically disregarded the plus s and the minus x because the values are so small that it won't really affect our answer. So then you get x is equal to 1.3 times 10 to the negative 3 molarity. And this x signifies the concentration of C3H5O3 minus in the resulting solution, which is equal to, again, 1.3 times 10 to the negative 3 molarity.